Hello, everyone. We have here our DICT ICT Proficiency Examination reviewer. So, we'll be covering several topics regarding the coverage of the examination. For now, we'll be covering one of its uh, general topic, which is the database concepts. So, the lessons covered under this database concepts, of course, we have the database itself, then database management system, relational database, structured query language or SQL, tables, primary and foreign keys, and normalization. So let's start with database. So a database is a structured collection of data organized for efficient retrieval, storage, and manipulation. So I guess that you're already familiar with this terminology because you have utilized this since you've started this topic starting your second year. But then again, this is just a review or a guide on what you need to uh, study most when it comes to in preparing for the ICT proficiency examination. So I believe you have also used database on your capstone projects, so you'll be more familiar with the term. So typically, our databases consist of tables, which is represented by rows, which are our records, and columns, which are the different fields which represent specific data entities and their attributes. So, for example, we have here an e commerce website. Um, So typically, an e-commerce website uses a database to store information, right? About the products they sell, regarding data about their customers, and then different orders made and the different transactions within the website. So typically, those types of um, data, that e-commerce website will have a storage for that, and that will be our database. So chances are, so let's just say the database consists of multiple tables such as products for our products, customers, orders, and transactions for those that have been mentioned earlier, each containing relevant data attributes corresponding to the need of the e commerce website. Now let us have the database management systems or DBMS. So, what is a DBMS? A database management system, or DBMS as we know it, is a software that provides an interface for managing databases. So it facilitates data storage, retrieval, modification, and deletion, as well as ensuring data integrity, security, and concurrency control. I think you're already, again, well aware of this one, of what DBMS is. So this is a software that typically you use to manage your database, your created database. Okay. So let's say, for example, you created a website. So typically we use MySQL or MySQL, right? So we do something like that. For others, for Java users, sometimes we use SQL Server, and then for other languages, we have the SQLite and so on. So those are actually examples of um, database management systems. So we have MySQL, PostgreSQL, Oracle Database, Microsoft SQL Server, and SQLite are some of the examples of popular DBMS software used to manage databases. So I believe some of these you're already familiar with, or chances are you have already used some during your 4-year course here in our uh, PSIT program. Now let's talk about relational databases. So a relational database organizes data into tables, of course, with rows and columns, and establishes relationships between tables using keys. So I think this is one of the most familiar terminology that you have encountered before. Remember, we have the diagram equivalent of this one, which is the entity relationship diagram, which basically presents the relationship from one entity to another. Remember, one of the other terms that we use to call entities are tables or relations. Okay. So our ERDs typically present relationships. So how one entity is connected to another and so on. To which we typically use those keys somewhat. These are the primary keys and foreign keys. So later we'll have a specific topic for that. So it follows the principles of the relational model, which defines relationships based on primary keys, foreign keys, and relational algebra operations. So, for example, let us consider that we have a student's database with different tables such as students, courses, and enrollments. So each table has rows, of course, representing individual students for the students' tables, different courses, or we should say subjects as we are more familiar with, and then enrollments, uh, transactions between students and courses as well, and columns representing attributes such as student ID for students, course name for course, and enrollment date for enrollments. Relationships between these tables are established using primary and foreign keys. So I will no longer show an entity relationship diagram because um, if I do recall the examination, we have not encountered uh, ERDs. But if there will be a chance that it will appear, so I would suggest try to have a recap, at least on the simple ways on how to uh, draw or illustrate an entity relationship diagram. Now let us have the structured query language or SQL. So this is one of the questions I do remember that appeared on the examination, but I think this it's just one question out of the lengthy topic of SQL. So, structured query language or SQL, as we're more familiar with, is a standardized language used to interact with relational databases. So, it provides commands for creating and modifying database structures, or what we call the DDLs, manipulating data, or the DMLs, and controlling data, which are the DCLs. So, let's dive deep on those three, giving you some examples or an example on each keywords that we can use under DDL, DML, and DCLs. So let's start first with the data definition language or DDL. DDL commands are used to define and manage the structure of database objects such as tables, indices, and constraints. So the main DDL commands in SQL are create, alter, drop, and truncate. So let's start with create. So this command is used to create a new database object such as a table, an index, or a view. So on this example, we just have a single one. We are creating a table employees. So within this one, we have our columns or our fields. We have the employee ID as our primary key. We have the first name, last name, and department as our other um, fields. So the command that we're seeing creates a new table on our database named employees, as we've mentioned, with these four columns. Now let's go with alter. So alter command is used to modify existing database objects, such as adding, modifying, or dropping columns from a table. Let's say, for example, we wanted to have email as part of our table employees, but then again, we already created the table. So one thing there is if we try to recreate the table again, we'll be encountering errors, right? So one thing there is for us to use alter. So on this case, we alter the table employees that we've just created, and then we wanted to add the field email. So this is the code for that. Next, we have the drop. The drop command is used to remove existing database objects such as tables, indices, or views. So these drop table customers, let's say, for example, we have a table existing named customers. So this command allows us to remove that specific table from our database, okay, of its entirety. Any row or any column stored, or I should say, we focus on rows. Any rows stored within our table customers will be deleted, even the table itself will be deleted. That is the use of drop, because this is for data definition. This is for the structure of our database. And then we have the truncate. So what's the difference of drop and truncate? On dropping, remember, we remove the table itself. On truncate, this is a command used to remove all rows from our table without deleting or removing the actual table. So let's say we have here truncate table orders. All of the rows stored within orders will be deleted, but the table orders itself will remain on our database, not like on drop. The table itself will be deleted. Now let's proceed with the DMLs, or the data manipulation language. DML commands are used to manipulate data stored in our database. So the main commands of DML are the following. We have the insert, update, delete, and select. So typically these are the CRUD operations. For data creation, we have insert. For data retrieval or data reading, we have select. For data modification, we have the update. And then for data deletion, we have delete. So DMLs are for our CRUD operations. So let's start with the insert. So the insert command is used to add new rows of data into a table. Okay, by the way, DMLs allows us to manipulate within our table or tables. So it allows us to manage the data within, not the table structure itself, because those commands are for DDLs. It's not for DMLs. So the insert command again allows us to add new rows. So let's say, for example, insert into customers. Um, if we provided something like this, a parenthesized arrangement of fields, that means that this is the arrangement that we should follow. If we do not provide this one, I'm pertaining to this one. Where is my mouse pointer? I'm pertaining to this one. If we do not provide this one, we need to follow the arrangement according to how we created the table. Okay? So customer ID will be 1, name will be John Doe, and email will be john@example.com. Values are thrown as part is a clause thrown within the insert statement as part of providing the actual values of our rows. Okay. Next, we have the update. Update command is used to modify existing data in a table. So let's say, for example, the simplest syntax of update is update our table name. On this example, it's products. Set your column equal to the new value. Where is our condition? Okay, we need to provide a condition if we do not want to change or modify all of our contents. Okay, it allows us to limit our modification. So on this example, where product ID is equal to 1001, meaning that specific product ID, that specific product on our example, we wanted to change its price to 29.99. Okay? Because if we omit line number 3, if we omit the where clause, everything on our products table, the price will be changed to 29.99 if we fail to include our where clause. So that's how crucial where clause is in data modification. Then we have our data deletion. So the delete command is used to remove rows from our table. So delete from our table where our condition, this condition allows us to be more specific. Which row are we planning to delete? Okay. Same with the condition on update. If we forget to include the where clause, it's like we do the truncate. Okay, everything from the orders will be deleted. Take note, delete from orders allows you to delete everything within your table, but not the table itself. Okay, again, as I've said, it's like truncate. It's not like drop. Okay, Drop deletes the table. Truncate deletes the rows. So same with this, if we fail to include the where clause, everything will be deleted from the orders table, but again, the table will remain. Now we have the select. Though there are too many clauses within the select statement, we have the select clause, from clause, where clause, group by clause, having clause, and the order by clause. We'll just focus on some of the simplest one. So we have here select asterisk from employees, to which again the purpose of select is for data retrieval. It allows us to select, or it allows us to retrieve data from one or more tables. So select asterisk. Asterisk means all columns will be selected from our specific table, which is employees, where we are trying to be more specific. We wanted to limit our selection. So here we added a condition. If we omitted our where clause, everything will be selected from our employees table. But on this one, we just wanted to select those under the sales department. Okay. So anyone, any employee under the sales department will be selected using this selection. Again, if we omit the where clause, everything will be selected. Now let's have the last category under SQL. We have the DCL, or the data control language. So these commands are used to manage permissions, okay, and access rights within a database. So typically we use the grant and revoke. So the grant command is used to provide specific privileges to database users, such as the ability to select, insert, update, or delete data from tables, create tables, or execute stored procedures. So typically, grant allows us to give our users on which specific access they could do on our database. Let's say, for example, we want to allow user one to have select and insert on our employees table. So we do this command like grant select, comma, insert, separating the two commands on our specific table to our database user. Okay. So the syntax is almost the same for revoke. So for revoke, by the way, revoke command is used to revoke previously granted privileges from our users, effectively removing their access to specific database objects or operations. So earlier, based on our example, we granted the permission for selection and insertion of data, right? But then we wanted to revoke data insertion. So what we could do here is to use the command revoke, and then the permission that we want to revoke, which is insert on this example, on which specific table, on our case it's employees, from our existing user, which is on this example is user one. Now let's talk about tables. Um, this is something short because this has been mentioned multiple times within our discussion from the start. So tables are the basic building blocks of a relational database. So each table represents a specific entity, which consists of rows and columns. So I think I no longer need to elaborate on that because we've been mentioning that since. So for example, we have an employees table. Each row represents an employee or a record of an employee, and each column represents the attributes or the fields of an employee. Let's say, for example, we have an employee ID, the name of our employee, on which department they belong, and their corresponding salary on their position. We can actually add position, rank, and anything that we could think of that is related to an employee. Now let's talk about primary and foreign keys. So we've been hearing this specifically regarding relational databases because relational databases live on primary and foreign keys. Because with these different keys, we can show or we can present the relationship. So let's start with the primary key. So what is a primary key? A primary key is a unique identifier for each record in our table. So the purpose of primary key is to ensure data integrity and provides a way to uniquely identify each row in the table. So primary keys are typically implemented using one or more columns that have unique values. Let's say, for example, on our case at Bulacan State University as students, your primary key basically would be your student number. Okay. So each of you has a unique student number. It will never be the same, even from the past students of the university. You can never find someone having the same student number as you because that is unique for you. Okay. So typically, we can use that as a primary key to identify that if we if we use your student number and trace it down on our database, we could see your record because that is you, that is your identity on our database. Okay. So something here was mentioned using one or more columns that have unique values. Primary keys can be a single column. Let's say your student number, but let's say we wanted to supply more than one primary key to make it uh, for us to ensure data integrity more. Okay. So let's say, for example, we can use email address. I think right now as well, since uh, all of our students were already given their email addresses under the bulsu.edu.ph domain. So we can use that as well. We can consider that as well as our primary key. So we can use your student numbers and your email addresses as our primary keys. And then multiple primary keys are called composite keys. Okay. So this was the example I have mentioned. So I think we can skip this one now. Now let's talk about foreign keys. So a foreign key is a column, or it could also be columns as well. Like our primary keys, it can be multiple in a table that establishes a relationship with another table's primary key. So typically, a foreign key is linking to a primary key of another table. Okay, to ensure that the value is the same, so we can direct, so we can point out to whom that data belongs. Okay, so foreign keys ensure referential integrity by enforcing relationships between tables. So foreign keys represent the many side of a relationship in a one-to-many or many-to-many relationship. So if we go back to the idea of entity relationship diagram, once we saw the many side, typically the foreign key is present on that many side. Now let's say, for example, in our orders table, the customer ID column acts as a foreign key. Okay, meaning there is a customer ID column on our orders table which serves as a foreign key, referencing to the customer ID column of the actual customers table. Again, we use that for referential integrity or for referencing for us to point out to whom that data belongs. So we do not need to fill out all of the information of that specific customer. We'll just use its ID to identify using its foreign key. So with that foreign key, we now establish the relationship between the orders and the customers tables. Now, let's talk about the last topic under the database concepts. We have the normalization. So, what is normalization? Normalization is the process of organizing data in a database to reduce redundancy and dependency. So, it involves dividing large tables into smaller tables and defining relationships between them to minimize data duplication and improve data integrity. So, in normalization, we just typically break down our database to something like smaller pieces so we can understand them more to reduce, as have been mentioned, to reduce redundancy on the contents of our tables within our database. So in normalization, we have typically three to four processes. Okay, let's start with the first normal form, or 1NF. In 1NF, each table should contain a single atomic value. So there should be no repeating groups or arrays within a table. So typically, what we are trying to omit on first normal form are the multivalid attributes. Okay, we just wanted to separate them out. Okay, so additionally, each column should have a unique name, and the order of rows and columns should not matter. So one thing on 1NF, it ensures data should be organized into rows and columns, each intersection containing a single value. So for example, we can split the multivalid attributes into separate columns or rows. As I've mentioned, we are trying to omit multivalid attributes during the first normal form. If we think after the first normal form, our database is not yet normalized, we can proceed to the second normal form, or the 2NF. One thing you need to remember before doing 2NF, make sure you've done 1NF. So after 1NF, what we're trying to remove under 2NF are the partial dependencies. So what are partial dependencies? Dependencies meaning that there are no non-key attributes that are fully functionally dependent, okay, that are not fully functionally dependent on the primary key, meaning all of the non-key attributes must be dependent on our primary key. Okay, there should not be any partial. They should be fully dependent, okay, on our primary key. So 2NF eliminates redundancy by ensuring that each of our non-key attribute is dependent entirely or fully on our primary key. Let's say, for example, one of the things here typically is on composite keys. Let's say we have multiple primary keys. Here's one thing that we need to check under 2NF. If a non-key attribute, when we say non-key attribute, those are our simple or atomic attributes that does not serve as our primary key. So those are the non-key attributes. Let's say, for example, um, as have been mentioned here, there shall be no partial dependencies. So meaning if we have composite keys, let's say we have two, for example, both our non-key attribute must be dependent on both primary keys, not just on one. Okay? Because that is a partial dependency. If our non-key is only dependent on a single primary key but not on both of the primary keys. Okay, that is partial dependency. So that is one thing that we wanted to omit during the second normal form. So let's say, for example, we think that after doing the second normal form, still our database is not yet normalized. Then we can proceed to the third normal form, or 3NF. So one thing here is, before doing the 3NF, make sure we've done the 2NF. So additionally, it should not contain transitive dependencies. So this is what we wanted to omit on our third normal form. So let's just have a quick recap. On our first normal form, we wanted to remove the multivalid attributes. On our second normal form, we wanted to remove partial dependencies. And on third normal form, we wanted to remove transitive dependencies. So what is transitive dependency? Talking about normalization. Transitive dependency meaning your non-key attribute is dependent on another non-key attribute. Okay? So let's just go back. When we say partial dependency, your non-key attribute is not fully dependent on your primary key. But transitive dependencies mean that a non-key attribute is dependent on another non-key attribute. So it's quite questionable because that is not even your identifier, and then it is dependent on that specific attribute. So meaning you need to create another table for that to suffice the third normal form. So one of the objectives of third normal form is to eliminate redundancy by ensuring that our non-key attribute is directly dependent only on the primary key. Okay. So like for this example, we need to create a separate tables to represent dependencies between those non-key attributes. Now there is another one, the fourth one, that we can consider, but we barely proceed on this normal form. We have the Boyce Codd normal form or the BCNF. So BCNF is a stricter version of the 3NF. So in BCNF, every determinant or attribute determining another attribute or our transitive dependency must be a candidate key. So meaning that specific non-key attribute where another non-key attribute is being dependent on should be a candidate key, meaning it is capable of being or serving as a primary key. So that is a candidate key. So this means that there are no non-trivial functional dependencies where the determinant is not a candidate key. So this is one thing that we are trying to omit on Boyce-Codd normal form. We wanted to omit the non-trivial functional dependencies. So it's like typically saying that there should be no issues existing within our table. Let's say I am trying to be dependent on someone which is not even worthy to be a candidate key, or when we meaning they are not worthy to be a primary key. Okay, so that's one thing that we need to avoid on BCNF. So BCNF ensures that the database is free from anomalies related to any non-trivial functional dependencies. So one thing, we need to split further. We need to remove those dependencies where the determinant is not a candidate key. So that is it for our database concepts review. If you wanted to know more, you can reach me at aaronpaul.delarosa@bolso.edu.ph, or you can reach me as well on my Facebook at paul.aaron3249.